Hi everyone, so this is the second video of the alkene video series. In this one, we're going to talk about the hydrohalogenation reaction. This is the reaction in which a hydrogen and a halogen gets added to an alkene. And we'll use this example for the steps in this reaction, and then we'll also do another one, another practice problem at the end. So for this reaction, what it's going to look like is that we have this reagent, which is usually an acid, and so it'll be something like HI, HBr, or HCl, which are the most common examples that you'll encounter. And in this reaction, we have the starting alkene, which I just highlighted in red, and we end up adding the hydrogen and the iodine across that alkene. And so what we'll see is that the hydrogen will go to one carbon and the iodine will go to the other carbon. And so we can see that we added in that H and that iodine, and then we now have a single bond where that alkene used to be. And so now we can talk about the mechanism for this. And again, I'm going to use the same example for this series, or for these steps. And so the first step in this reaction is that the alkene acts as a nucleophile. And so if we recall from the previous video, alkenes have a lot of electron density. And so what those alkenes want to do is attack that hydrogen, and then the electrons in the HI bond go to the iodine. And so that will be the first arrows that we draw in our mechanism. After that, we end up forming a bond between one of the carbons of the alkene and the hydrogen. And so if we think about our structure, and I'm just going to copy this over here really quickly. If we think about our structure here, we actually have two potential positions where that hydrogen could go. We have two carbons that I just circled in green. And so the hydrogen is going to go to the less substituted one. And so this one happens to be the right one in this molecule. And so what that means is we're going to draw the hydrogen bonded to that bottom carbon, or the one that's less substituted. In this example, we have unequally substituted carbons. So we have a preference for the hydrogen being placed on that bottom carbon. In the event of equally substituted carbons, we actually get a mixture of products. And so you would end up drawing both potential outcomes. And then we're not quite done yet with this step, because what we can see is that this carbon that I just highlighted in red over here doesn't have 4 bonds. And so because we initially had that double bond there, we're actually missing a pair of electrons there. And so what we end up having is a carbocation intermediate there. And so I'll copy this over again. And usually people draw steps 2 and 3 in the same step. I'm just kind of separating them out just so we can talk about what the different components of the reaction are. But in that second step of the mechanism, steps 2 and 3 combine to give you this intermediate here. All right, so now step 4. Here we have to take a moment and look at the intermediate that we formed in step 3, which I just boxed in red. And so at this step, we have a carbocation intermediate, and we know that carbocations can undergo rearrangements. And so the rearrangements, we have to stop here and look to see, will a rearrangement happen? And if we recall from our rearrangements chapter, we know that rearrangements happen when we can make a more stable carbocation. And so generally that really happens only if we have a secondary carbocation, because you can make a tertiary carbocation or a resonance stabilized secondary carbocation if you have a methyl or a hydride shift. But here we have a tertiary carbocation. And so since we have a tertiary carbocation, we don't get any rearrangements and we can move on to step 5. And the practice problem that I'll do at the end of this video will have a rearrangement. So we'll kind of talk more about what steps 4 and 5 will look like when we do have a rearrangement. And so in our question here, we have no rearrangement because we have a tertiary carbocation, and tertiary carbocations are already some of the most stable carbocations we can get. And so rearrangements are pretty infrequent. All right, so we're going to skip step 5, but I'll quickly talk about it. So it's not going to be relevant for our practice problem here. But if we do have a secondary carbocation and we could potentially form that rearrangement, then we would draw that rearrangement and we would have that extra step within our mechanism. And again, we'll do a practice problem with that in a second. But as a reminder, we're looking for either secondary to tertiary carbocation rearrangements or a secondary to secondary with resonance rearrangement. All right, so now we can take a look at our last step. And so for this, I'm going to copy over our mechanism from here. And so now we formed our intermediate here, and we decided that there's no rearrangement. And so in the last step, the iodine that we formed in the first step of the reaction with that extra pair of electrons, we'll end up attacking that carbocation because that iodine has an extra pair of electrons and it can act as a nucleophile. And so then we end up having this as our final product. And I can draw in that hydrogen if we want, but for skeletal structures, we don't need to. And so one thing I want to point out is that that attack in this step can come from either side of that carbocation. And so on this carbon here, we have a mix of stereochemistry. And this isn't actually a chiral center in this example, but in general, we actually end up having both the wedge and the dash orientation for the added halide for our products. And in different reactions, you might know the stereochemistry, but in this one you don't, and you get a mixture. All right, so this mechanism in this row over here is the full mechanism for this reaction. It's just a two-step mechanism when there's no rearrangements. All right, so now let's do an example with a rearrangement. And so I'll kind of go through the different steps. And so in that first step, again, that alkene attacks that hydrogen, and those electrons between the hydrogen and the bromine go to the bromine. And so in that first step, we form a bond to a hydrogen and a carbocation. And so to decide which carbon gets that carbocation, we look at the two different positions. And we can see that this carbon right here is more substituted. And so our carbocation will go there, and then that hydrogen will be added to the last carbon. And one thing I want to point out here is make sure that you don't accidentally drop a carbon. Some people will add the hydrogen, like they'll draw a hydrogen where that red spot is. And because of that, they'll end up losing a carbon. But just keep in mind that you want to make sure you conserve the total number of carbons that your starting molecule had. All right, so now here we're at, we did steps 2 and 3. And so now we're on step 4 to pause and kind of think about, can we get a rearrangement? And so we get rearrangements when we have a secondary carbocation. And so we can see that this is secondary. So that means we want to look for a rearrangement. And when we're looking for rearrangements, we're looking to see, could we get resonance stabilization or a tertiary carbocation? And we don't have any double bonds here, so we can't really get resonance stabilization. However, we see that there's a position, and I'll highlight this in green over here, where we could potentially have a tertiary one. And we do have an available hydrogen here, and I'll draw that in, and I'll kind of zoom in so we can see it a bit better. We do have that hydrogen there that could undergo a 1,2 hydride shift. And so we end up forming that tertiary carbocation in that position at that tertiary site where it's more stable than that secondary one. And so that will be step 6 from above, or step 5. And then finally, our last step is going to be that bromine that we formed from the first step, coming back in and attacking that carbocation and forming a bond there. And again, we don't want to show stereochemistry here because that bromine can come in from either the top or the bottom of that planar carbocation. All right, so that wraps up this video. On this next video, I'm going to have a bunch of practice problems. So we're going to go through this entire list. I would recommend trying these on your own first and then watching the video solution key to make sure that you got everything right. And all right, I'll see you in the next video.